Okay. Is the voice audible now? Hello. Hello, hello. Okay. वांटेड गेयर, इतने दिनों के बाद याद आया कि सिलेबस कंप्लीट करवाना है। सॉरी फॉर द डिले, थोड़ा पेड क्लास का बैचेस में बिजी था। ठीक है, अभी से डेली होगा क्लासेस। फ्रॉम नाउ ऑन we'll have regular classes. Sorry for the delay, I was busy with the paid classes. Okay, fine. Answer this question. W are x such that x comma w belong to a comma b plus. What is this language? What is this language? WWRX. Sir, can a first year student join in Parakram 2027 batch? Yes, Suryaram, you can join Parakram 2027 batch even if you are first year. Sir, how many more lectures will it take to complete TOC? So till 15th of December we'll have classes. Till 15th of December we'll have classes. Okay. Okay, answer this question. W power r x such that x comma w belong to a comma b. Right? Answer your question in the Telegram channel. I'm seeing Telegram channel. Answer your question in the Telegram channel. I'm seeing Telegram channel. Adesh, write your answer. W or X such that X comma W belong to A comma B plus. Asmita, I am not asking you for grammar. I am not asking you for grammar, Asmita. So you have given the grammar, and your grammar is WWR, and then WWR followed by, it can generate only S. Where are the terminals? Where is the anchor condition? How are you going to terminate S? How are you going to terminate S, Asmita? In your grammar, you cannot terminate S. WWRX such that X comma W belong to A comma B plus. WW power RX such that X comma W belong to A comma B plus. Adesh, Roshan, I am seeing the Telegram channel. Please answer it in the Telegram channel. Roshan has answered. Very good, Roshan. Your answer is right. Adesh, give your answer. Adesh, give your answer. WWRX such that X comma W belong to A comma B plus. Okay. So how are you going to solve this? So we have devised a method, right? For all these questions, we are going to follow the same method. Let us assume that this is L1. Let us assume that this is L1, right? Now we will get L2. In L2, in W we will put A. In W we will put A. In W we will put A, right? So we are going to get A, X. And what is X? A plus B plus whole plus. So this is what we got for L2. Now write L3. In W we are going to put B. In W we are going to put B. B, X. Now what is BBX? BB followed by A plus B whole plus. BB followed by A plus B whole plus, right? Now the question is, you have to check if L1 is equal to L2 plus L3, or if L1 is superset of L2 plus L3. L1 is proper superset of L2 plus L3, which means, are there any strings which cannot be generated by L2 and L3? Are they present in L1, right? Can you answer it now? Can you answer it now? Can you answer it now? L1 equal to L2 plus L3. Either this one should be right or this one should be right. You can answer it now. Okay. Okay. So how are you going to answer? Take some W which is not A or B. Take some W and see W power R X. See W power R X. Okay. See W power R X. Right. Right. So take some W which is not A or B and try to see if that string can be generated by either L2 or L3. If that string can be generated by either L2 or L3. Yeah, actually, Titan, I was not feeling well, so I have taken only 25 minutes of the class. But in this course, we are going to complete it. Okay. So Turing machine was not completely done in crash course, because in crash course we cannot do complete, but this is a complete course. This is not crash course. So in this course we will see completely about Turing machine. Compared to crash course, this course will be comprehensive and it will contain all the topics. Okay, so you can follow this course I don't think that there is any course similar to this on the internet. Okay. So you can follow this course. I will cover everything related to Turing machines. In fact, I will cover everything related to TOC. Okay. WWRX, right? WWRX. With the 2 months, maybe 2 months may not be really sufficient for GATE exam. Please join for Parakram 2027 batch. Okay. Please join for Parakram 2027 batch. 2 months might not be sufficient to complete entire GATE syllabus because it is too lengthy, right? So this time you can just do the crash courses and give the GATE. But for next year, you join Parakram 2027 batch, and PW has the best faculty. You will definitely get a good rank if you work hard. Okay. Next year, you try for Parakram 2027 batch. Okay. So how are you going to answer this? Let us say W equal to AB. Let us say W equal to AB. Let us say W equal to AB. Then what about WWRX? This is going to be AB, BA, A plus B whole plus AB, BA, A plus B whole plus, right? Now, even if A plus B whole plus takes away everything, even if A plus B whole plus eats BA, AB is remaining, right? AB is remaining. Now, this AB followed by A plus B star is not a part of L2 or is not a part of L3, right? Similarly, if you take W equal to BA, then what do you get? W power Rx is going to be BA and WR is going to be AB X. BA, AB, X. BA, AB, X. right? Now it is BA, AB, A plus B whole plus. Even if A plus B plus eats up A plus B, you still have BA, right? Now this BA followed by A plus B plus, it does not belong to either L2 or L3. Therefore, there are strings which are not in L2 and L3, which are in L1. So, L1 is strictly a superset of L2 and L3. L1 is strictly a super set of L2 and L3, right? So what can we say? So we can say that the language is not regular, right? The language is not regular, and we know that any language of the form WX, WR, all these are context-free languages, right? So the language is context-free language, okay? Sir, how many lectures it will take to complete the TOC course? Please respond, sir. Sai Kiran, entire TOC course will go till 15th of December. By 15th of December, we will complete the entire TOC course. By 15th of December, we will complete entire TOC course, okay? Okay. Okay. Now let us see what is a derivation. The process of deriving the process of deriving a string the process of deriving a string from a grammar the process of deriving a string from a grammar is called derivation. The process of deriving a string from a grammar is called derivation, right? For example, if we have something like this, S derives AB, A derives A or epsilon, B derives B or epsilon, B derives B or epsilon, A derives A or epsilon, B derives B or epsilon. Then what is derivation? S derives AB, S derives AB, and A derives small a, and then B, and then B derives small b. B derives small b, right? So this process is called derivation. Step by step deriving a string is called derivation. Step by step deriving a string is called derivation. Now there are two types of derivations. Now there are two types of derivations. One is leftmost derivation and other one is rightmost derivation. Now let's see leftmost derivation. Leftmost derivation, right? Right? In every step of derivation, 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 if there is a choice, if there is a choice in variable substitution, if there is a choice in variable substitution, if there is a choice in variable substitution, and leftmost variable and leftmost variable is substituted, if leftmost variable is substituted, then it is called leftmost derivation. Then it is called leftmost derivation. Then it is called leftmost derivation. If there is a choice in variable substitution and leftmost variable is substituted, then it is called leftmost derivation. Then it is called leftmost derivation. Then it is called leftmost derivation, right? So for example, if you have this grammar, S derives AB, I'm taking a simple grammar so that you'll understand it. A derives A or epsilon, B derives B or epsilon. Now, by reading the definition, try to do leftmost derivation for AB. By reading the definition, try to do leftmost derivation for AB. Right? By reading the definition, try to do leftmost definition for AB. Right? So, what we can do is, initially S derives AB. Now we have two variables. There is a choice. Either you can replace A or you can replace B, right? Now, if you replace A, that is called leftmost derivation. At every step, leftmost variable is replaced first. Now there is no choice. We have only one variable, so we have to replace that, right? AB. So this is leftmost derivation. This is called leftmost derivation, right? Now let us see rightmost derivation. Let us see rightmost derivation. Let us see rightmost derivation. Okay. So in every step, of derivation, in every step of derivation, if there is a choice, if there is a choice in variable, if there is a choice in variable substitution, if there is a choice in variable substitution, and right rightmost symbol is substituted. You can say rightmost variable, and rightmost variable is substituted. Rightmost variable is substituted. Then it is called rightmost derivation. 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 Then it is called rightmost derivation, right? For example, if there is a grammar S derives AB, A derives A or epsilon, B derives B or epsilon. Now try to do rightmost derivation for AB. Try to do rightmost derivation for AB. Try to do rightmost derivation for AB. Right? We have done leftmost derivation. Similarly, you can do rightmost derivation for AB. So I have taken a very small grammar just to explain you this concept. But when you go to compiler design, we are going to see some difficult grammars. And why is leftmost derivation and rightmost derivation important? Because top-down parsers will do leftmost derivation and bottom-up parsers will do rightmost derivation in reverse. Bottom-up parsers will do rightmost derivation in reverse. Top-down parsers will do leftmost derivation and bottom-up parsers will do rightmost derivation in reverse. Okay. So S derives AB, and B derives B. So AB and AB. So we are replacing the rightmost variable first. This is simply a rightmost derivation, right? This is simply a rightmost derivation, right? Now you know what is a derivation tree. I will tell you later, okay? So what is a derivation tree? We'll discuss it now only. Derivation tree. Derivation tree. So root must be S. Derivation tree's root must be S. And every expression must correspond to some production of G, So root must be S and every expansion must correspond to some production of G. Every expansion must correspond to some production of G. Then the yield must be a sentence. The yield must be a, you can say, word. The yield must be a word. Okay, this is a derivation tree. And you know about derivation trees, we have seen the derivation trees without seeing actually what is a derivation tree, right? We have seen derivation trees earlier. Without seeing the definition of the derivation tree, we are able to see them. I will just give you one simple example. Let us say S derives AB, A derives AA or epsilon, B derives BB or epsilon, right? So what happens? S derives AB, A derives AA, A derives AA, B derives epsilon. So this is a derivation tree, and every expansion corresponds to a production here, right? This is a derivation tree. Now what is the relationship between leftmost derivation, rightmost derivation and the derivation tree? What is the relation between leftmost derivation, rightmost derivation and the derivation tree, right? So for every derivation tree, for every derivation tree, for every derivation tree, there is only one LMD, there is only one LMD and one RMD. For every derivation tree, there is only one LMD and one RMD possible. There is only one LMD and one RMD possible. For every derivation tree, there is only one LMD and one RMD possible. If W belongs to L, which means if a word belongs to a language, L of G. If G is a grammar and L of G is language generated by the grammar, if a string W belongs to L of G, if a string W belongs to L of G, there will be at least one derivation tree. There will be at least one derivation tree. There will be at least one derivation tree and at least one and at least one LMD, at least one LMD and at least one RMD, at least one RMD, right? If a string belongs to the language, there will be at least one derivation tree, there will be at least one LMD and there will be at least one RMD, right? Now a grammar is ambiguous. A grammar is ambiguous. A grammar is ambiguous. A grammar is ambiguous. A grammar is ambiguous if a grammar is ambiguous A grammar is ambiguous if it has a grammar is ambiguous if it has only one. A grammar is ambiguous. Let us first write about unambiguous. Okay, a grammar is unambiguous if it has only one derivation tree, only one derivation tree for any string in the language, So only one LMD or one RMD, only one LMD or one RMD are possible. 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 Right? Now what is ambiguous grammar? What is ambiguous grammar? What is ambiguous grammar? A grammar G is said to be ambiguous. A grammar G is said to be ambiguous if there exists a word W belong to L of G. If there exists a word W belong to L of G such that it has more than one derivation tree. Right? So if there exists a string W in a language such that if it has more than one derivation tree, then we can say that the grammar is ambiguous. But ambiguity is undecidable, which means there is no algorithm which can say that a grammar is ambiguous, right? And there is no algorithm which can say for what string you are going to get more than one parse trees, right? So you have to do practice. With practice, you will be able to come up with strings in such a way that you are going to get more than one parse tree, right? There is no algorithm for this. In an ambiguous grammar, in an ambiguous grammar, we may have more than one derivation tree more than one derivation tree. In an ambiguous grammar, we can have more than one derivation tree. In an ambiguous grammar, we may have more than one derivation tree, more than one derivation tree. In an ambiguous grammar, we may have more than one derivation tree for a string. More than one. In an ambiguous grammar, we may have more than one derivation tree for a string. For a string. So there may be more than one. There may be more than one LMD and RMD. More than one LMD and RMD. Right? If in unambiguous grammar, every string in unambiguous grammar, every string has exactly one RMD, exactly one LMD, exactly one derivation tree. Exactly one derivation tree. So what does this mean? If the grammar is unambiguous, every string that is generated by the grammar has exactly one LMD, exactly one RMD, exactly one derivation tree. Exactly one derivation tree, right? If this is talking about a string, not about a grammar, right? If a string W has one derivation tree, if a string W has one derivation tree, by implication, which means if and only if W has one RMD, by implication, if and only if W has one LMD, W has one LMD. if W has one derivation tree, W has one RMD, and W has one LMD, right? If W has at least if W has at least one derivation tree, if W has at least one derivation tree, that implies by implication, if and only if W has at least one RMD, W has at least one RMD, by implication, if and only if W has at least one LMD, W has at least one LMD, W has at least one LMD. Okay. So tomorrow we will see. So tomorrow we will see how to identify ambiguous grammars. Okay. I will tell you some rules. There is no algorithm for this, but we can guess using some rules. Okay. But there is no guarantee that you will always be able to identify a ambiguous grammar. There is no algorithm. With practice and with some rules, we can have some guidelines. Okay. Thank you everyone. Good night. Jai Hind.